video, I'm going to describe the constructing evidence-based explanations practice in the context of the to reflect or not to reflect, that is the question data puzzle. So the goal of this practice is to help students finalize new understandings about science ideas as they relate to the investigative question by constructing an explanatory model. So for this practice, we really need to help students understand what a scientific model is and what are the different signs and symbols, modeling conventions that can be useful in connecting different parts in a model. We have students construct a gotta have it checklist before constructing their final model. Given that students have engaged with an opening scenario, a reading, some data analysis work, there's a lot for them to take stock of. And so identifying what are the key ideas, concepts, what evidence do we have to support these ideas and concepts, and creating a list that has these things is critical scaffolding to help students successfully construct a final explanatory model. And once we've done those things, students can then construct their final models either individually or in pairs. So again, students have just gone through the data analysis piece. They've revisited their initial predictions and refined those predictions based on the data, the evidence that they just saw. Again, looking at the relationship between albedo and sea ice extent. Now it's time to construct this final model to explain the investigative question: how might the Arctic's albedo be affected by the observed decline in sea ice? But before we're ready to construct that final model, we need to figure out what a model even looks like. So we found that it can be really helpful to look at an example model together with students. And in this case, in my classroom, I always had success making connections between Marvel movies and what I was talking about when applicable. So over here, we've got a annotated SketchUp model representing the Marvel movie about Black Panther. And so the task here is, once we introduce the concept of a scientific model, these are visualizations that can be used to explain questions they're investigating. We want students to think about what are the different parts that should be included in a scientific model. So relevant concepts, and we want to connect different concepts using signs and symbols. And if we have any data or evidence, can we infuse that into the model as well? And so we have students identify these 3 bullet points as they show up in a model for the question: why does the Black Panther get stronger after being punched? And so you can see we've got some different ideas, including the deposition of vibranium, this element that shows up in the key, and then a zoom in window to show vibranium being mined and then infused into the Black Panther suit. So some of these different parts show up and are connected with different signs and symbols. We've had teachers utilize this slide, print it out, and give it to students when constructing their models, because it can be really helpful for students to see that as they're connecting ideas. So signs and symbols that connect parts. Arrows can be useful to show movement or connection between parts. Keys can help us define symbols that show up many times throughout the model. Zoom in windows to show what happens on a really small scale. Timelines to show changes over time. So some of these signs and symbols that students can think about, and how to infuse those into their models. Before students can use those signs and symbols, they first need to develop a gotta have it checklist. So this is their opportunity to reflect on all that they've done and create a list of ideas, concepts, and evidence that they think needs to be in a model to explain how the Arctic's albedo might be affected by the observed decline in sea ice. So on the student worksheet, there's a space for students to jot down these ideas and the evidence that supports these ideas. And then many times we encourage teachers to have students share out ideas and concepts and evidence, and together as a whole class decide what goes on a consensus gotta have checklist. So that we co-construct this checklist on a piece of butcher paper or whiteboard, only ideas that everyone agrees on goes on that whole class gotta have it checklist. That checklist then becomes what students refer to when thinking about how to construct their models. They need to include everything on that gotta have checklist. After this scaffolding is done, it's time for students to construct their final models, making sure to consider which parts they're going to include and how to connect those parts. Again, they're trying to explain the investigative question, how might Arctic's albedo be affected by the observed decline in sea ice? And here's the graphic that they're going to annotate. So you can see on the left, we've got more sea ice, the right, less sea ice, and we're thinking about how the albedo might differ between the two images. Many times after students construct their models, we encourage some model sharing to help students learn with and from one another. And so many times this happens through a gallery walk. Students may leave their models on their desk or taped up against a wall, and then students can kind of circulate around the room to see what their peers have come up with. We've had teachers in the past give students sticky notes to add questions or make comments about things they like about their peers' model and leave them around the room as they circulate. And the final piece of all data puzzles is to help students dig a little deeper in their thinking about the concepts that they engage with in the data puzzle. And in this case, we want students to think about how the decline in sea ice, we know how that decline in sea ice affected the Arctic's albedo, but how might that decline in sea ice also affect temperatures in the Arctic? And so we've got a data visualization here that seemingly shows that the Arctic is warming rapidly, and in fact, it is warming more rapidly than other parts. Other areas on Earth. So why might that be? How might the decline in sea ice be contributing to that? After students have answered this question and discussed this question, that concludes the to reflect or not to reflect. That is the question data puzzle.